So I am Malithi, PhD student at Southern Illinois University. Today I will be presenting our work titled Development of Fall Detection and Safety Construction System using Small Language Models. This is a collaborative effort by our teams at the Southern Illinois University along with the partners from the Colorado State University and Kankanamge Science and Technology University. In the construction site, most of the workers are working, and the fault is the most problem in the construction site. So, according to the Occupational Health and Administration and Bureau of the Labor Statistic, so in the 2020, faults case to 351 out of the 1080 deaths. So, and the 2021, there's a 37% of the deaths in the construction due to the falls. In 2022, falls from the elevation along due to the tree and 95 out of the 1069 facilities. So, why existing systems are insufficient? In the existing systems can detect the falls and it trigger the alerts. So they typically have a lack of continuous communication, which is integrated with the emergencies. Our objective was to address this gap between developing a novel fall detection system, especially for the construction site. We designed the system to integrate the small language model and like TinyLlama and Phi-3 that can generate an immediate fall alert, and more importantly, it engage with the real-time continuous conversations with the emergency team. We also built a lightweight machine learning fall detection model that can operate a resource construction constrained environment, and we tested our approach using simulations with the realistic data and evaluate the system accuracy, relevance, and response speed. In the related work section, there's a video-based fall detection in the construction site. There are several studies explore the computer vision-based approaches. For example, Liu, they introduced a non-content process detection system using k-mean clustering. The card, they introduced a combined computer vision with EMU sensors and altimeter to the monitor workers at the height. So, and another work is using the scale YOLOV for large and a single object detector to detect the four workers. It produces the detection in the consistent inference time, making them far better to real-time applications than the two-stage detector. So, however, these methods largely detect the pole, but it not provide the continuous communication support for the after detection. This is another related work, industry-based related work. So the company Signage, it produced the real-time fall detection with the CCTV, and the Viact is another company. It produced the automated video monitoring for the falls, and Source Safety is another company. It provided a wearable and it provided alert for the supervisors. The Quent is another company. It has a small device for the workers' falls. And Always AI is another company. It detects the object and specific activities, including fall detection. So, and Visionify is another company. It's a sleep. It detects the fall detection with the camera AI. So these companies also these companies also improve the detection and alerting, but it does not provide the continuous communication support with the emergency response teams. Turning into the large language models and small language models. So in the large language models like OpenAI GPT-3 and GPT-4 offer the expansional performance because of their massive scales and diverse training. However, they are costly. It requires the significant computational resources and challenging for the fine tuning for the domain specific tasks, especially on the resource limited hardware. On the other hand, small language model like a TinyLlama and Phi-3 far better suited for our needs. With the efficient fine-tuning technique such as low reft, we can adapt these models to specialized and this is ensuring to deliver the fast content aware responses even in the limited devices. This is our proposed method. It integrates two major component fall detection module, which use the YOLO V8 to detect the people in the real time from the video feed. And we tested this on the UR4 dataset. It determined a fall by computing motion threshold, and if it is below 0, it classify event as a fall. And also there's another module in the small language module which use the TinyLlama and Phi-3 models. We fine-tune these models on the synthetic emergency dialogue generated by the ChatGPT to simulate the realistic interaction between the system and emergency response team. You can see there's a dialog box. It has the communication with the emergency response team and our SLM agent. This is the results of the fall detection module. So it YOLO V8 can perfectly identify the person, and the fall detection module identify the fall workers fall, and after that it generate the alert with the informations about the person and locations, those details by using the local database. Result of the small language model. So without fine-tuning, TinyLlama and Phi-3 produce largely irrelevant responses. So after fine-tuning on the synthetic images conversation, TinyLlama complete with the 50 examples. It taking the 57 minutes to training. So Phi-3 it took roughly 5 hours to training. So after the training, so it produced the correct responses, and both models shows the steadily decrease in the loss. It indicating the successful learning in the emergency dialogue patterns. Here you can see the TinyLlama respond without the local database. With the local database, so adding the local database is to greatly improve the consistency. It provides the details like locations. It's correct. It will correctly provide the locations of the workers, locations, and flow level across the multiple questions. So we need the local database because we need to have correct responses about the workers and information about the location. We compare in the TinyLlama before and after fine tuning. It shows a hug difference. So without fine tuning, the model often give the generic incorrect answers. So after the fine tuning, it consistently gave the precise context aware responses to the relevant to the emergent situation. It also shows the same pattern. So without the fine tuning, it fails to maintain critical details about the conversation. So after fine tuning, Phi-3 provided more relevant and accurate responses to the emergency response team. In summary, before fine tuning, both models struggle to maintain correct informations and continuous interactions about the emergency response team. So fine tuning on the synthetic dialogue drastically improve this. So it enables us to precise answers to the emergency response questions, the emergency response team. So in the 100% accuracy maintained in the critical, we are using the local database. So regarding the response speed, so Phi-3 was the slightly faster than TinyLlama. So both models show low speed of the response after fine-tuning due to the richer content, but they will still quick enough to support real-time emergency conversations. So now with much higher relevance and accuracy after the fine-tuning. To conclude, we developed a novel fall detection system that combines lightweight machine learning with the small language model. This approach overcomes major shortcomings of traditional system by supporting continuous context-based communication, which is crucial in high-risk construction environment. So future work, we plan to integrate wearable sensor data to improve detection, expand our training data sets to include more diverse scenarios, and I hope to benchmark adjacent large language models to better understanding trade-off between size, speed and performance. This is the reference. Thank you for your attention. Thank you.